Paul, I want to thank you very much for coming on and spending some time with us today. We are very excited to catch up with you. And as Garrett mentioned, disruptive technologies is something that we're going to talk about today. We hear this term, disruptive, and but tell us what that really means.
Sure. Well, disruptive innovation is a term that describes any technology which could change the current paradigm. And typically in order to do that, something has to represent a 50% improvement gain above and beyond what we already have today. And if something is 50% less expensive or can have a higher efficiency, it can potentially move technologies out of place which are currently used today.
Just looking back briefly before we dive into some of the newer disruptive technologies, over the last maybe decade or so, are there any disruptive, what would you call today, maybe that was disruptive a decade ago, that's become common practice?
Sure, well, I mean, just to anchor it in a commonplace example, the iPhone is probably the best example of a disruptive technology in that a touchscreen phone completely wiped Nokia away. Now, when we look at the water sector for similar examples, disruptive technologies would include membrane bioreactors, for example. Like 20 years ago, that was a very new technology, not widely accepted. Today, it's a commonplace technology. Ultraviolet disinfection was also disruptive as a disinfection technology when it came to market as well.
Right. There's a couple of technologies in particular that I really want to talk to you about today, and one of them is nutrient recovery, because we hear a lot more about nutrients, certainly in the US, for sure. In the rest of the world, I'm sure it's an issue as well, where we have excess nitrogen, we have phosphorus issues. These are causing problems downstream in other water bodies, and so we're really trying to take a look at those. And it's also about recovering the resource, right, and using it elsewhere. Give me your thoughts on nutrient recovery in general, sort of where we are, where you think we might be going with that.
Sure. Well, nutrient removal is probably the next major regulatory hurdle facing wastewater treatment plants to protect receiving waterways, and it really focuses around nitrogen and phosphorus. Right. And they're two very different nutrients with very different technologies. The recovery is really best thought of, it's low-cost compliance. So if you can remove it and create a revenue stream from doing that, which allows the municipality or the utility to have a lower cost compliance, that's a very strong driver.
Right.
Phosphorus is getting more mature. Well-established companies and players on struvite recovery, such as Ostara, Neurosys. Nitrogen is now where the shift seems to be going, towards nitrogen, ammonia recovery, nitrogen removal, with some very interesting examples of biotech being used, alternative biological pathways, as well as recovery of ammonia as a valuable fertilizer.
Right. So you talk about fertilizer, and we've heard stories and we've seen evidence of municipalities really finding that revenue stream, right? I mean, they're coming up with these. Is it how big of a revenue stream could they expect to get out of something like that? I mean, does it make it worth the investment in the technology?
Yeah, well, if you were in the fertilizer business, you wouldn't open a municipal wastewater treatment plant.
True.
That's probably a good way of putting it. That's not the most profitable place to mine nutrients, but if you're going to remove it anyway, I mean, if it really helps you to offset your costs, then it is quite attractive. And people are getting more creative about that, and particularly some of the companies you see here about how they can approach with a very strong value proposition linked to the circular economy. And I think it can offset costs. I don't think it's going to be profitable on its own, but it can certainly help make it more effective.
Right. And the struvite recovery that you mentioned, and that has some other benefits too, right? I mean, from what I understand, it makes it tackles some of the corrosion issues that plants face.
Yeah, in actual fact, a lot of the people put in struvite recovery, it's about blocked pipes, so it's actually a different driver. It was causing an operational headache, it was blocking up all these pipes, and they could solve that problem, and at the same time they could create a product which has a value. And that's a real win-win. Right.
You mentioned Ostara. We certainly hear a lot about them. Are there other major players in that space that you would...
There are. It's getting quite crowded, actually. We recently completed a report on phosphorus recovery, and what we saw is that the struvite space is getting crowded already, and it's becoming quite an accepted technology. I mean, Chicago has put in a major phosphorus removal plant with Ostara, but there are at least 6 or 7 other players, many in Europe, such as PAC in the Netherlands here, that are all active. And it's, I think, in terms of technologies, it's moved pretty quickly. Over 7 or 8 years, that technology has gone from demonstration to accepted. Right. Well, let me move on to my next topics. This is going to be very interesting. Energy is one of the biggest concerns in the wastewater space. I mean, this is, most of their capital expenditure is going toward, 50-60% is going towards energy. That quest to become energy neutral,
Tell us about that. Where are we in that challenge right now?
Well, it's here. We're already there in that there are many plants that are already energy neutral. Some are very high profile, like the Strass plant in Austria, East Bay Mud in San Francisco. You could probably point to a dozen currently, so it is being done from North America and Europe, and to my mind it's only a question of how that rolls out to the broader market now. A lot of the focus is on carbon diversion, pulling carbon back and sending it for energy recovery. It's creating a very interesting landscape, and another major innovation is around low-cost aeration systems.
Right.
Particularly, I would say the membrane aerated biofilm reactor is been the technology to watch in the past 12 months.
Yeah, absolutely. Yeah, how are utilities making that value proposition? How are they justifying? I mean, eventually if they get to the energy neutrality space, it becomes self-justifying, right? Because they're not using the energy and they're recreating enough to be neutral. But in the meantime, how do they justify that investment?
Well, it's a shifting landscape at the moment in that no one's quite sure where it's going to land in terms of the dominant technologies. When it comes to an upgrade or a retrofit as a plant reaches capacity, that's a very good time that they can look at moving to energy neutrality instead of adding additional capacity, pulling more carbon back.
Right.
So you've got the retrofit market and the greenfield new build market. One thing it's probably worth saying is that no one's quite sure how the interplay of energy neutrality and nutrients are going to interact with one another.
Because there's some overlap there?
One impacts the other.
Yeah.
You know, as you move to energy neutrality and you pull carbon back, that impacts how you remove the nitrogen.
Okay.
And when you choose a nitrogen solution, you have to bear in mind what you're going to do with your energy side of it.
Right. Right. Well, that's an interesting point. Okay. Well, we'll be watching that for sure. One other thing I wanted to ask about, we hear a lot about Animox.
Oh, yeah.
Where do you see that going, or where is it maybe, and where do you see it going?
Well, again, a technology developed here in the Netherlands addresses the energy issue of nitrification, reduces nitrification energy, reduces some carbon costs as well, so it addresses the energy headache and the nutrient headache. Very attractive. It has done very well so far on side stream treatment, and now the next thing people are looking at is how it can go into the mainstream treatment process, mainstream deammonification, shortcut nitrogen removal. It's the next challenge.
So how to bring it into the mainstream is really kind of...
That's where the focus is currently,
right.
yeah. That's what we're seeing.
Yeah. Last thing I want to talk about, biotechnology. It's a big fancy word for bugs, right? So how does biotechnology fit into the wastewater space, and where are the really exciting innovations?
Well, again, this was something we looked at this year at Next Generation Biotech. We did a Blue Tech Insight report on that topic, and because behind every wastewater treatment plant, the workhorses or the worker bees are bugs or bacteria, and we believe there are some major innovations and advances in biotech that are coming into water. Animox is one. Deeper understanding of biotech is allowing us to be more efficient in how we purify and treat wastewater.
Right.
And one to watch would be what's called biocatalysis or microbial encapsulation with companies like Microvi, Lenticats, Nanospun Technologies out of Israel, which are taking next generation biotechnology and applying it into water, which can reduce footprint, reduce capital costs, save energy.
Wow, that's really interesting. What about things like endocrine disruptors or like those kinds of emerging contaminants? Does biotechnology have a role there?
People have looked at how you can use enzymes to break down some of those endocrine disrupting compounds, very targeted ways of dealing with contaminants, so it certainly does, and with things like perchlorate, some of these trace levels of chemicals where you can get particular bacteria that are targeted at those and can remove them.
Yeah, okay, that's really super interesting. Now, just before I let you go, any other observations or anything you want to just kind of let people know about what to watch for in the wastewater space?
Yeah, I would say a few things that I'm picking up over the past 6 months or so would be water as a service. So we're all familiar with software as a service. Water as a service is becoming more common in that lease-based operations where the supplier is delivering it as a service. That's enabling new innovations to be delivered to market faster. Predictive analytics, better analytics to predict how plants are going to operate is also a major theme that we're seeing. So those would be two. Okay, well we will keep our eyes on those. And Paul, thank you so much for being with us today. We really do appreciate it and wish you all the best going forward. Thanks very much.